Hey folks, I think I'm live. We had a couple of small issues here. Uh, I couldn't join the Google Live event for some reason. I guess I'm live now. Let me just check if everything is all right. Just give me a second, folks. Just checking if everything is all right. Uh, I couldn't join the Google Live event for some reason. Yeah, makes sense. Yeah, I think I'm live now, thankfully. Yeah, we had some hiccups because for some reason I couldn't join the YouTube live session. Okay, I think we are okay enough. Am I audible, folks? Just let me check the audio also, just to make sure. Give me a second, folks. Just give me a sec. Just give me a sec. Am I audible now? Folks, can you just confirm on the chat window if I'm audible now? Because I can hear myself if when I unmute, right? Just let me check the audio also. Yeah, I can hear myself. No issues with that. Okay. Okay, sounds good, which is good. Okay, so no issues with audio. Okay. For some reason, I was not able to join in for the last 10 minutes almost. I was struggling to join in. Okay, so let's get going then. A couple of important announcements before we go in. Since I'm audible enough, let me just stop all streams, everything, so that you get the best bandwidth out here. So a couple of major announcements. If there's any hiccup, do let me know. I'll keep the chat window open right next to me. Okay, so a couple of important announcements, which are tomorrow and day after. Sorry, tomorrow and 20th. So 18th and 20th, we'll give you 2 subject tests for C programming, which will cover the whole breadth of all the topics that are there. So most of the contents are over. There are a couple of small miscellaneous topics that some of you have emailed us. Some of you have requested us to add. While some of them are not part of GATE syllabus, we would still add them. Why not? Because we have a couple of days, right? So for example, I just added enumerators right now, which are anyway in GATE syllabus. We'll be adding about the C preprocessor, a function, a bunch of examples, and like conditional like hash if def and things like that, right? We'll also cover a couple of topics on how to debug your C programs, which will just help you become a good programmer. So I'll add some of those miscellaneous topics over the next couple of days. Every student who is lagging behind, please catch up now. Okay, the plan right now is on 18th, which is tomorrow. Hopefully by afternoon of tomorrow, we'll send out a message and an email to all of you with 1 subject test. We'll have the 2nd subject test ready by 20th, right? So by 21st end, I want all of you to be on track. I know some of you are lagging behind because we track the progress of every student. I understand some of you may also have exams. I completely understand that. That's why we're giving you more time to catch up now, right? So from 22nd onwards, 22nd is a Monday, right? From 22nd, we'll start linear algebra. Probably linear algebra will take us like 4 to 5 days to finish. Okay, so we'll start linear algebra from 22nd. But since some of the final year students have exams starting from April 20th up to May 15th, we'll go slightly slow there. And we'll also be covering a bunch of topics which are easy for students to revise back. Okay, so we'll be doing slightly lesser amount of content. Maybe, I mean, we'll not go at full throttle, so that students who are in final year who have exams can also, or people who are in 3rd year who have exams right now, can also quickly cope up with us, right? So we want to give that. So that's why from 22nd of April till 15th of May, we'll go slightly slow, maybe about 60 to 90 minutes of content every day. I know there are some of you who are doing long term who want to do it fast. For those of you, we anyway have tons of stuff for data structures, algorithms, and C. People who are in batch 2, you can start data structures, algorithms parallelly, right? Because all the content, all the practice tests, everything is there. People who are in batch 1, right, will do linear. So for all of us, so please catch up on everything. From May 15th, because we have slowed down a little for the next 3 weeks, starting from April 22nd to May 15th, we'll speed up again. So from May 15th, once exams are over, we will double down. We will do 3 hours of content a day. And from then onwards, there shall be no slowing down, right? Till the time our course is complete, we want to go full throttle. It's a trade-off. We had to make a trade-off now. We don't want to slow down, but we have to respect some of the students who are in BTech 3rd year and final year who have exams. So those of you who are doing full-time, who are doing long term, please accommodate these students. We all have to go together. And from May 15th, we'll double down full speed, right? So just wanted to clarify that. There are a bunch of topics that I'll keep adding in miscellaneous topics over the next couple of days. Like we got some good emails about some more concepts, some more examples. We'll keep covering them. So I have created a new chapter called miscellaneous topics where I just added enumerators a while ago in the afternoon, and I'll keep adding more content slowly one by one. These all are not too important from a gate perspective, but it's good to know. Why not? Since we have a couple of days, since there are some students with exams, let's cover them in more detail, right? So somebody's asking how to revise for data structures, algorithms, and C, right? So since you have two subjects, my suggestion for those of you, the best way is whatever notes you have written, just quickly go through them. That's the first step. That's like a conceptual revision. Then go back to the book C in depth, start solving the exercise problems if you want to revise C. I really like that book. Okay, C in depth by Srivastava and Srivastava. So just go through their, they have a third edition also, which I really like. So just go through the practice problems. It's a very well written book, very nice practice problems, number one. Number two is for data structures algorithms, go through Corman's practice problems. Most of them have solved examples online also, right? So, but limit yourself or focus yourself more on the syllabus that is there for GATE. Okay, because we have that single-minded goal, right, to crack GATE. So the best way is to start solving problems from these good textbooks, because that gives us enough material to practice and to revise, right? So those of you who are doing long-term or who think that they're slowed down from April 22nd to May 15th, please do some of the exercise problems here. Anything that you're stuck with, please revert back to us and we'll help you through that process. So my recommendation for revision is quickly go through the conceptual revision, all the notes that you've written, number one, then start solving problems. There is no better revision than starting to solve problems. So you can start solving problems from the exercises in the textbooks, the two textbooks that I mentioned, which is C in depth and CLRS. The third area that you can also do is look at the last 30 years of GATE questions, right? Solve all the C and data structures algorithms problems. There are a huge chunk of them, by the way, because I think C data structures algorithms in total is like some 15 marks or so, if I'm not wrong. Again, it varies slightly. So, oh yes, please send us any question you have when you're practicing, right? If you have, somebody's asking if I have a question in previous year GATE questions, please do send them. Why not? First attempt, okay? First put in your heart and soul, attempt it thoroughly. Only when you're stuck, please send an email and we'll help you through that process, okay? But let's focus on C data structures algorithms so that, again, the other thing is let's all last 30 years question paper C data structures algorithms, right? That's another great source and it's very focused towards GATE, because the CLRS questions or C in-depth textbook questions may be slightly above or below GATE level, some questions here and there, but GATE questions are at GATE level by default, right? So, okay, so Mahesh is asking about questions in CLRS. We'll work on it. We haven't collated all the questions from CLRS which are at GATE level, but we can start doing that. We'll certainly work on that. That's a good suggestion. Again, today's topic is structures and unions. The very few questions in the previous and files, right? The very few questions from previous year GATE questions. That's why we just had to actually artificially create 10 questions for the practice. Let's dive into that, finish that, and come back. Okay. So just give me a second. I'll answer these 10 questions. And these 10 questions are very straightforward and easy. Okay, we can finish them quickly. Let me just share the screen. And okay, so let's go in here. Let's go in here. Yeah. So I hope all of you can see my screen now. Right, I hope no issues. Let me just zoom this also. Okay, so this is my full screen anyway. So let's solve question by question, right? So what is this first question? This is a question about enumerators, right? So I've added this video in the miscellaneous topics. So there is a chapter called miscellaneous topics where I'll add a bunch of random topics, right? Like enumerators, like preprocessors, function pointers, etc., which are not very important from a GATE perspective, but let's just cover them anyway, right? So I've just uploaded this video. You can watch that, where if you watch that video, this is a trivial problem. And if you already know about enumerators, this is a trivial problem. So what am I doing here? I'm creating an enumerator data type called day, which has the following values that it can take: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So by default, when you create an enumerator data type called day, the Sunday will get a value. Sunday by default gets a value of 0 because this is the first identifier, right? This is the first identifier value that a variable of type enumerator day can take, right? So what about Monday? So Monday has a value of -2. Remember, -2 is also valid because it's an integer value, right? So as we discussed in the miscellaneous topics video, which I uploaded in the afternoon, if I'm not wrong. So Tuesday will be -2 plus 1, which is -1. What about Wednesday? Wednesday is 5 because I'm pre-allocating this Wednesday value to 5, right? Thursday, I have not allocated any value, so it will be 5 plus 1, 6. Friday, I'm pre-assigning, not allocating. I'm pre-assigning a value called 8, right? What about Saturday? I'm not pre-assigning any value, but since Saturday comes after this value of Friday, this has a value of 9. So now those are the internal representations of these identifiers, right? As we discussed in the course videos. Now, if you look at this function, it says int main %d. This is perfectly all right because all of them are internally represented as integers, right? My Sunday equals to 0, my Monday is -2, my Tuesday is -1, so on and so forth. I'm just simply summing these things up. If I sum all of them, right, I'll get a value of 25. You can just sum it manually and check it. Okay. If you sum all of them, you'll get a value of 25, right? 17 plus 11 is 28. 28 minus 3 is 25. Yes. So it would actually print 25, and 25 is the right answer here. Very simple problem. If you know what enumerator is, how the initialization of the integer values corresponding to each of these identifiers works, this is a straightforward trivial problem, right? So that's question 1. Let's go to question 2. Okay, this is a slightly more interesting. I have a structure called player, and I'm creating a global variable called PL. Okay, the structure player has a player name, which is a character array. Okay, very good. Now I have this function here called char star play. I have a function here, very good. Here is my main function. So what am I doing here? String copy pl.pname coli. Okay, so what am I doing? I have a variable called PL, right? So PL is a structure which has a p name, right? P name is a character array. P name itself is a character array. So into this, I'm copying a value called coily. Okay, into this, I'm copying a string called coily. So perfectly all right, no problems with this statement. Now let's see what I'm doing. I'm saying printf %s space %s. Look at this. The first one that will be executed is here, is this. It says play address of PL. Okay, so let me go to play this function. And the function takes the parameter, which is a structure player pointer. And what am I passing? I'm passing the pointer to P1 or PL here. Sorry, I'm passing the pointer to PL here, right? So the pointer to PL goes here. Now what does it say? It says, so what is a formal argument here? Temp PL. So temp PL is a pointer. That's why I'm using the arrow operator here. Temp PL p name equals to Dhoni. Remember that this temp PL. Remember that the temp PL, right, is pointing to P1. Right, the temp PL is a pointer to P1 because I'm passing the address of PL here, right? Which means this value now is no more going to be Kohli. This value is going to be Dhoni now, right? And what am I changing? I'm changing the value that is there in pl.pname because I've passed the address of PL here, right? So this is like passed by reference, right? So I've already printed this. Now what am I saying? Return temp PL p name. So what would this return? This would return a string called Dhoni, right? And it's returning a character pointer. Very good. So what will be here? Because the play function itself returns this Dhoni string. What will be printed here? Dhoni will be printed here, right? Dhoni will be printed here, and there is a space after that. Next, what is the next thing that I'm going to print? pl.pname. Because I passed the address of PL, which means I passed by reference, pl.pname also got changed as Dhoni internally, right? So the first string that was printed was Dhoni because it was returned by the play function. The second string that is being printed is pl.pname, and pl.pname got changed from Kohli to Dhoni internally in this function, right? So again, I'll print Dhoni, right? So it is Dhoni space Dhoni, not underscore Dhoni space Dhoni. That's the answer. And that's option C here, right? If you look at the options here, It is option C, right? So option C is the right option here, right? Very simple code, simple pass by reference, simple structures, nothing very fancy out here. Okay, so let's go to just a second. Let me see the comments. Okay, so it will be Dhoni Dhoni. Yeah, sounds good. So everybody got that, which is good to know. So now let's go to question 4, right? So now let's go to question 4. Okay, this is a slightly interesting one. This is very interesting actually. So let's go step by step for this also. Okay, so let's go step by step. So here I have, okay, I think they forgot to put stdio.h here. There is a small typo here. I think they should have put hash include stdio.h. I think that's a typo here, right? So I'm creating a structure called list, which has an integer and a character pointer. And look at this. This S is an array. What is this S? This S is an array of lists. Is an array of struct list. It's an array of struct list, right? That's what this array, this S is, right? Now, this S, now look at this. What is this S? S is an array, right? What is the size of the array? We don't know. We're just assigning these values. So what will happen is, because the structure has one integer and one character array, this will become S0, right? So this will become S1, these two. This integer and this string becomes S1. This integer, this string will become S2. This integer and this string will become S0, right? So now let's go to the main function. Now what am I doing? I'm saying struct list. So I'm creating a pointer to this structure and I'm assigning it the value of S, right? Remember, S is the name of the array, right? So this pointer PTR is now going to point to S, right? So PTR is a pointer to your array S. Now let's look at this. Let's go step by step, right? So what is the first one that we have? PTR plus plus. We have PTR plus plus arrow CH. This is what we have. This is anyway post increment, right? Since this is post increment, the first thing which will happen is it will print PTR CH. First, it will print this. And what is PTR CH? PTR is pointing to S, right? PTR, basically PTR is a pointer to this whole array. Or in other words, to be more precise, PTR is going to point to the S0 term. So to be precise here, PTR is going to point to the address of 18. The address of 18, that's what it's going to point to, right? And its data type is, it's a pointer to the structure list, right? Now PTR CH, okay? What does PTR CH do now? Because I have an integer and a character, because PTR is a pointer to the structure list, the arrow operator, right? The arrow operator. Now what does PTR CH mean? PTR is pointing here. PTR is now pointing here, right? So PTR CH is nothing but applied. So it will actually print applied now. Okay, it will first print applied. Then it will increment PTR. Look at this. First this is because this is post increment. First I print PTR CH. And what is PTR is pointing to this now, to the 0th element of my array, or to the address of this very first place, right? So now it will print applied. Very good. It has printed applied. But then PTR has to get incremented. What is the data type of PTR? PTR is a structure pointer, which means if I increment it, what will happen? It will stop pointing to this. It will stop pointing to this. And it will start pointing to the next element in the array, right? Because PTR's data type is structure list, right? If I increment it by 1, it will go to one record. See, this is one structure element, right? This is other structure element. This is other structure element. So it will point to here, right? So that's what happens now. So it printed applied. Very good. Now let's go and see what happens in the next step, right? In the next step now, what do I have? So this is done. I have plus plus PTR. I have plus plus PTR arrow CH. Now what does plus plus PTR mean? This is pre-increment, right? And PTR is of type structure list. Okay. So what does increment of PTR means? Now PTR will no more point here. PTR will point to 20. Okay, because I'm incrementing the PTR itself. When it is pointing to 20, I'm saying print CH. Okay, which means what is the CH here? This is A and this is CH, right? Right? CH is a character pointer pointing to this course. Now, when I print this, what happens? I get applied space course, because there is a space here, right? So I get applied course. So this part is printed. Very good, right? Now, what is the next step now? Let's look at the next step now. Okay, so this step is also good, done. The next step here is minus ptr within braces 1 dot a. Now let's see what happens. Now I have to perform decrement of ptr. So when I decrement ptr, what happens? This whole thing will again go away, and ptr will now point to 19 because it was initially pointing to 20. When I decrement it, it will point to 19, right? Then it says go to index 1 from here. So what does, see now with this, we have already evaluated this. With this, it's going to point to 19. Now I'm saying go to the first element here. If this is the 0th element, go to the first element. The moment I say go, because this is pointing to this is the 0th element now, this will become the first element, right? So this is same as saying like, go to the next element, right? Which means now again ptr will start pointing to, now again ptr will point to 20. Now within, when it is pointing to this, when it is pointing to S2, right? We were saying print A. What is the A value here? 20. So it will print 20 now. Okay, so this is also done. Next look at what do we have. Now it says, okay, so we have done this, very good. Okay, we said ptr1, but where is ptr pointing to now? See, look at this. Where I said minus ptr, right? When I said minus ptr pointed to 19. But when I said ptr1, so this is what ptr1 points to now. So, or minus ptr1, that's what, okay? But what is ptr pointing to effectively? ptr is still pointing to this only. ptr is still pointing to this, right? After this decrement, 1 basically makes it point to here, right? So this whole thing is going to point to 20, right? But ptr itself is pointing to S1 even now, right? Now what does it say? ptr0a, which means ptr is pointing here. Don't take any steps now because ptr0 is same as ptr now, right? So it is going to point to this, right? And now it's saying dot a. What is the value of a here? 19. So it will print applied course 2019. Okay, that's what it will literally print now. So which is option C, right? Yeah, there is no space here. So it will print 20 here and it will print 19 here. So it will end up printing applied course 2019. Right? The important part here, the important lesson here is the PTR is a pointer to structure list, and you have to understand how increments and decrements work for that and how array indexing works on this. That's all. It's a very simple problem. You just have to be careful with this pointer arithmetic. Just for that, you have to remember that this PTR is a pointer to the list structure. If you're careful about it, you get the answer. Okay. So now let's go to fifth question. Now let's go to the fifth question. Okay. So fifth question is more or less straightforward. The size of the union. So we have a union called ABC where you have an integer, float, and character. Assume that integer is 2 bytes, float is 4 bytes, and character is 1 byte. Okay. What is the size of the following union? We already saw this, right? When we learned unions, it is a max of the sizes of all these 3 elements. Obviously, it's going to be 4. Instead of it being a union, if it was a structure, it would have been 7, right? Because 2 or 7 or sometimes even more actually. Okay, again, that depends on how structures are internally stored. There's a lot of compiler specific modifications there. As far as unions are concerned, it is 4. It will just store the maximum of 2, 4, and 1. Okay, structures have some, 7 is one possibility if it were a structure, but there are other possibilities also. Okay, so now let's go to 6. These are simpler questions, right? Which of the following is not true? Not true about a structure. Okay, so let's go through this. So structures are used to construct a complex data type in a meaningful way. Makes sense. We can also declare an array of a structure. Why not? A structure can be nested inside a structure. Yes, why not? We cannot pass a structure as a function argument. We can, no? And it's asking which of the following is not true. So this is the statement which is not true, because we can pass structure as a function argument because it's just one of the data types that we have, just that it's a user defined data type, right? So let's go to question 7 now. Okay, the following C declaration, look at this declaration. I'm creating a struct node, right? I have in this struct node, I have an integer and a float, and then I have a semicolon here, and I'm declaring a variable like this, right? Look at what I'm declaring here. I'm declaring a variable like this. Now define S to be. Okay, what is it? Look at what it is. Okay, S, if you think about it, it's an array. S is an array, right? S is an array. Okay. Remember, I'm not saying this. I'm not saying this. Okay, that's okay. So what is S here? S is an array. True. An array where each element, where each element is a pointer to a structure of type node. Makes sense, right? See, array is a pointer of, sorry, S is a pointer of 10 elements. And what does each element here have? See, it's a pointer of 10, it's an array of 10 elements. 0th element, first element, second element, so on and so forth, up to 9th element. And what do each of these elements are? These elements are pointers to struct node. Yes, that's what it is. So A seems to be the logical thing, right? A seems to be correct, because S here is an array of structure node pointers. Okay, that's all there is. Okay, very simple statement here. And now to be more precise here, your parenthesis has a higher, look at this, you have your parenthesis here and you have your dereference operator here, right? Your parenthesis has a higher precedence over the dereferencing operator, right? Hence it is an array of structure node pointers. Okay, this is very important. Okay, I hope you understood that. Okay, so let's go to question 8 now. Okay, so what is this question 8? Okay, let me just scroll down. Okay, let's see what it does. I have a structure called course with course number and course name. Very good. So this is a structure. This is my main. Okay, I'm creating a array called C. This array, the first C0. So this is what is present in C0. C0 has 102 and C. C1 has 103 and C++. C2 has 104 and Java. Now what am I printing first? I'm printing C1.course number. C1 basically means this. C1.course number means 103. So it will print 103. Very good. Next, look at this statement. This is an interesting statement. It says star C+2. Okay, everything in parenthesis dot course name. Now let's see what this means, right? So value stored at C+2. We know from the array 2, we know that whenever we have A2, we wrote this as value stored at A+2. You remember this? We discussed this multiple times also, right? So what is this? This is nothing but C2, right? This is the simplest way to understand conversion from the array notation of indexing to the pointer representation, right? So this is nothing but C2. C2.course name is what it is asking for. And what is C2.course name? Nothing but Java, right? So it will print 103 space Java, okay, which is option 3. Very simple question. If you know, see, if you know that this is equal to C2 for any type of array, this is the simplest way to understand the array indexing and the equivalent pointer representation. Again, we'll come to that. Okay, there is a small announcement that I also had to make. Okay, so let's go to question 9 now. Consider the following statements about structures and unions. It is necessary that all the elements in a union should be same. No, not necessary. S1 is not right, right? So 1 second. It is necessary. 1 second. So S1 is false, right? S1 is false. What is S2 now? The dot operator can be used to access structure elements using a structure variable. Yes, this statement is correct. The size of the union is equal to the size of the largest element. Yes, S3 is also correct. Which of the following statements are incorrect? Okay, only S1 is incorrect because S2 and S3 are correct, right? That's it. Very simple. Nothing very fancy here. Again, these are very simple questions, and because we didn't have because there are very few questions in GATE from these topics typically. Okay. So which of the following is true about this? So if I actually create a file pointer like this, what does it mean? So file is a keyword in C. No, file is not a keyword in C. File is the name of a structure, right? So it says file is a structure and FP is a pointer to the structure of file type. Yes, this is true. So B is true. File is not a stream. File is the name of a structure. File is a buffered stream. No. File here, capital FILE, is actually the structure whose name is file, right? So it's actually a structure internal. File is a structure and FP is a pointer. So option B is the right option here. Okay, that's all. Very, very simple exercise this time. And just give me a sec. Let me just stop sharing the screen quickly. Okay. Actually, okay, sounds good. So a couple of quick stuff that I wanted to tell you. For the last time, for the last live session that we did, if you all noticed, we also added almost a 45-minute video under the last live session video. We pinned it also, where the two problems that I was I actually didn't mess it up. I think I wrote the notation incorrectly there. I think what the mistake I did was I wrote a plus 2 equals to a2. That's a wrong notation. It is star a plus 2 equals to a2. I think that the mistake that I did in the last live session was a notational mistake, not so much of a conceptual mistake. But apologies for that. I've also put a detailed video for the two questions that I skipped with more context. So I've done 3-dimensional arrays, 4-dimensional arrays, much more detailed video under that last live session video itself. Additionally, we've also added that video into the course videos. Okay, we also added that video to the course videos so that you can go through it. Okay, so I hope that helped some of you. Just a second. Yeah, sounds good. So yeah, this was an easy session because there are very few problems from these topics and we wanted to keep it short. Yeah, so that's what it is. Yeah, just I hope you all understood the announcements that I made a while ago, which is that tomorrow 18th and 20th, which is tomorrow, and tomorrow is 18th, and on 20th we'll give you two subject tests for C programming, and please try to solve them. Please try to revise everything in C. If you're lacking behind anywhere, please cope up with it. For those of you who have exams, all the very best. Please focus on the exams. We'll cover some very simple topics and also smaller amount of content. The volume of content also will be small, such that when your vacation starts from May 15th, you can quickly grasp these topics. Okay, all the very best for your exams. Focus on them, get good marks, perform well in your exams. I understand that your BTech score is not important for GATE, but why not get good marks, right? So all the very best. So somebody's asking about static scoping and dynamic scoping, right? I can do it. I'll tell you what is dynamic scoping, but the point here is C only uses static scoping. C does not have dynamic scoping at all, right? I think the only language that I used which has dynamic scoping is Perl. Yeah. Perl, I think I can choose if I want dynamic scoping or static scoping. That's the only programming language. There are other fancy programming languages like Clojure, etc., which have dynamic scope. But yeah, we can cover that, or we could cover it in compiler design and stuff like that. But the point is, I can probably I'll try to add a miscellaneous video on that. It's a short snippet of video just explaining you what is dynamic scoping, what is static scoping. But C anyway uses static scoping. It doesn't use dynamic scoping. Again, dynamic scoping has its own challenges, issues, all of that stuff. That's why it's not very popular. And I remember when I wrote Perl code, wherein there are some esoteric programmers who would use dynamic scoping, and it's a nightmare to debug through what's happening and why the code is not working. Anyway, I'll make a note of this topic. I'll add a short snippet of video defining what dynamic scoping and what static scoping is, right? So it's a very simple concept. Somebody's asking about question 7, right? So let me go through that. What is question 7? Just let me see. I'm just sharing the screen again. Sorry, let me just go to question 7. What is question 7? Okay, question 7. You're asking why not, one second, why not option B, right? That's a question. So what is option B? A structure of two fields, each field being a pointer. A structure of two fields. What does a field here mean? A field here means, I think, these two things. It's a structure. See, S is not a structure, right? Look at this. B is not the right option. I think you're confused here. So define S to be. What is the definition of S? S is an array. S is not a structure, right? S is a structure of three fields, a structure of two fields, right? It's not a structure itself. It's an array. So B cannot be an answer. I hope you're clear about that, right? See, what is S? S is an array, right? Because parenthesis has higher precedence over star. It's an array of pointers of type structure node, right? So S is not a structure. S is not a structure. Okay, look at this. Only A and D can be true because S is an array to start with. Just that, see, D is also not true because S is, so what does this read as? What does, if I choose option D, what will S be? define S to be an array. Yes, it's an array. Each element of which is a structure. No, each element of it is a pointer to a structure, right? So it can either be only A or D, because S itself is an array to start with, and it cannot be D. It cannot be D because each element is not of type node. It's a pointer to type node. Okay, I hope this is clear. Okay, I'm glad you asked that question. I hope this is clear now. Okay, I hope this is clear. Just give me a sec. Let me go to the live session. I skipped question 3. Okay, let me see. Probably. Oh, 1 second. Let me see. Did I skip question 3 by mistake? Just a second, folks. 1 second. Oh, okay. I think I skipped question 3. I'm sorry. Thanks for reminding. I think I directly jumped from one question to other question. Okay, let's solve this anyway. I'm glad you asked. Okay. So you have a structure here called address. Very good. It has a character array, and an integer. Next, I have another structure here called person. Very good. This person has, this person has a character array, a gender, and another structure within a structure. Just that the structure address is not defined within the structure, but there is a variable called locate, which is part of this address. Okay, so now let's go here. So what does it say? It says star. Let's look at this. Star ID arrow name plus 2. Okay, can be used instead of which of these 4? Okay, let's see. Very good. This is a very good question. Okay, star ID name, right? Oh, 1 second. Is my screen not shared? 1 second, folks. Oh, my screen. Oh, sorry. Sorry, my screen is not shared. Sorry. Let me just share my screen. My bad. Let me just share the screen. Sorry. Okay, I hope you all can see the screen now. Sorry, my bad. Okay, I'll just repeat it. Thanks, Ravin, for just checking that out. Thank you. So we have a structure called address, okay, which has a character array, and a pin. Okay, I have another structure. Here. I don't have any structure name here because structure name itself is optional. This is perfectly valid. I'm just creating a variable called person of this structure type, right? Now, what do I have? I have a character array here. I have gender, and I have a variable called locate of type structure address. Very, very good. Now the question here is, then let's look at this term here. Okay, this expression, ID name plus 2. ID name plus 2. Okay, can be used instead of which of these 4? Very good question. Okay, so let's go step by step. Okay, so let's look at what this is. Okay, so what does star of ID name? Look at this. ID is pointing to person. Look at this. ID is pointing to person. So ID name. What does ID name means? ID name is nothing but person name, right? ID name is nothing but person.name, right? That's what it is, right? Because ID is a pointer of this structure type pointing to the address of person, right? So it is a person's name. What is person's name? Person's name is this, right? Person's name is this part. This is your person's name, right? Now it says plus 2. So person's name, what is person's name? Person's name is a character pointer, because we know that array names are nothing but character pointers, right? So person.name is a pointer. What is this? This is a character pointer pointing to name 0. That's what it is, right? To that, I'm adding plus 2. Remember, this has precedence, right? So that's why first this is evaluated and then plus 2, because everything is in parentheses. When I say plus 2, what happens? I'm adding 2 to a character pointer, which means now what happens? Now because of plus 2, it will point to name 2. It will point to name 2, right? So this whole thing is nothing but value stored at name 2. That's what it is. Or to be more precise, instead of writing it as name 2, the better way to write it as is, this is basically name plus 2. Okay, let's not write it as name 2. So this is name 2. 1 second. So let me write this. I don't want to mess up the notation again. Okay, name is a pointer pointing to name 0. It's a character pointer. I'm adding 2 to it. Imagine if the name here was A, B, C, D, E, F. Right? Name is going to point to this. Name is going to point to this. Name plus 2 will point to this, right? Name plus 2 will point to this. And I'm saying value stored at this, which is same as name 2. which is same as name2, right? So what do I get finally? I get a character which is at the third location from the beginning in the person.name. Okay, that's the result that I'm getting here by evaluating the string, the expression that I'm given. Now let's look at each of these. Okay, let's look at each of these now. Okay, this part is clear, right? What is person.name plus 2? Person.name plus 2. Let's see what it is. Okay, person.name. What is person.name? It's a character array, right? Person.name is a character array, which means you can think of its data type as character pointer. So I have a character pointer and I'm adding 2 to this. What do I get now? I get a character pointer. What do I get now? I get a character pointer. I don't get a character. We realized that this is equal to, this is the character that is stored at the third index, or this is the character. The resultant of this is a character which is stored at name2 within the person. Okay, to be precise, this is character at person.name2. That's what it is. But person.name is a character pointer and I'm adding 2 to it. So what do I get? I get a character pointer. Here I have a character. This expression results in a character. This expression results in a character pointer. So they can't be used one for the other. Makes no sense. So A cannot be the answer. Now let's look at B. Okay, what is B? B is ID arrow name plus 2. Okay, let's look at this. What does this mean? Name plus 2 here, right? First of all, ID arrow name plus 2, right? Okay, so the problem here is the variable name is not explicitly there. Okay. Oh, sorry. There is this arrow. Sorry, this arrow has the same precedence like the parenthesis, right? This arrow has the same precedence like the parenthesis, and everything is evaluated left to right. Sorry, I should not do name plus 2. I should evaluate from left to right, right? So ID arrow. So what does ID arrow means? It means we have come to person, right? ID arrow basically means person dot, right? We saw this. The pointer arrow is same as the variable name followed by dot. So now ID arrow is same as person dot. So person dot name, right? Person dot name plus 2. That's what it is. Again, if you think about this, this is also a character pointer. This is also a character pointer and not a character. Hence, B also cannot be an option because this expression evaluated to the character at person dot name 2. The first and second ones are resulting in a character pointer. A character pointer cannot be same as a character, right? So A and B are ruled out. What about option C? Let's look at option C now. Option C is value stored at ID dot name plus 2 and a star here. Now let's see what happens. What is the value stored at ID? Value stored at ID is nothing but person. Okay, so this is person dot name, right? Person dot name. Very good. Person dot name plus 2. Okay, so what do I have now? I'm at the second, because person dot 2 is a character pointer. I'm adding 2 to this. Okay, this is a const character pointer. When I add 2 to this, I go to the second. So I go to name 2. Okay, so what does this do? This does name plus 2. Okay, let me not write this. I don't want to mess up the notation again. So what does it say? It says value stored at person dot name plus 2. What is this equivalent to? This is nothing but person dot name 2. Right? Because of the equivalence between the pointer notation and the array indexing notation. This is what your initial expression also evaluated, right? This expression evaluated to the second character. See, this is a character now. This is a character, right? This is a character. Perfectly all right. So this is exactly same as this, because this was evaluated to the second character. This was evaluated to person.name2's character. And this is also evaluating to a character which is stored at person.name2. So option C is the right option here. Okay, slightly careful with the notation. That's it. Okay, and remember that star ID is same as person here. Okay, or otherwise star ID dot. Okay, so that's it. It's a very simple problem. You just have to be slightly careful. Okay, so sorry. Let me stop this. Hey, thank you for pointing out that I missed the third question. Sorry, my bad. Okay, so just give me a sec. Okay. Yeah, thanks for letting me know that I missed the third question. Very, very important, right? So 1 second. how do I now go here? Okay, that's okay. So yeah, that's all I had to share with you today. And yeah, thank you for joining in. And the next live session that we'll have, again, we'll start rolling out the content for linear algebra and some of the miscellaneous topics here. Since somebody's asking about static scoping, dynamic scoping, it's not very relevant to GATE. But anyway, since we have a couple of days now, it's a 10-15 minute video. Why not do it? Okay. So I don't know. By the way, if you have encountered any GATE question, the topic of which we have not covered here with respect to C programming, please let us know. When you're practicing some of these practice problems, right? We try to go through as many problems as possible so that we don't miss out on anything. But there might be one odd case that we miss out. So those of you who are revising some C data structures, because we're going to go slow till May 15th, if you encounter any question whose topic or whose details we have not covered in the course, please do send us an email. We'll immediately add that topic. Okay. Okay, folks. All of you who have exams, all the very best. Please put in your heart and soul into them. Yeah, I understand they're not important for GATE, but do well. Why not? Okay. Okay. See you folks then. Have a good day. Bye-bye.